All right, solving rational equations. Step 1, what can x not be? So x cannot be 0, because that would make 0 in the denominator. Next, we need common denominators. So we're going to multiply the first one times 2x, top and bottom. The second fraction is perfect. The last one we need to multiply times 4, top and bottom. My pen is running out. Where did I put my other pen? I had another pen. Oh no. Oh, times 4, right? Top and bottom. So that's 8. Now only write down the numerator. Only the numerators, and then solve it. So add 1 and then divide by 2. That's a good answer. It doesn't match that. All right. What can v not equal? Make the denominators the same. So we need to multiply this times v. So I end up with 1 plus v is equal to 6v take away 6, and then solve it. Combine like terms. And then divide. And you have your answer. Look what p cannot equal. For a monomial, it's always going to be 0. Now make the denominators the same. So for this one, I'm going to multiply it times 3p. And I'm only going to write down the numerator. So 3p times 1 is 3p. The second one's going to stay the same. And this one I'm going to multiply by 3, top and bottom. So be careful. It's negative 3p. And it's negative 18. Be careful with that negative. Now we're going to solve it. So we're going to make it equal to 0. So I'm going to subtract 3p. That's negative 6p. And then negative 45 and negative 18. Well, that's some big number. What is that together? Negative 63. Is that right? Is that even factorable? I'm going to find out right now. I'm in no mood to factor that. Got my cheating calculator here. Yep. All right, let me help you with that. I would never give you something like that to factor. So, p plus 3 and 5p take away 21. Those are the factors. So from the first factor, it's negative 3. And from the second one, it's 21 over 5. 48. Again, monomials. K cannot equal 0. Make common denominators. So I need to multiply this by 2k squared. That makes 6k squared. I need to multiply the next one by 3. And then the last one I need to multiply by k only. That way every denominator is 6k squared. Now the numerators. I'm first going to expand. Then I'm going to combine like terms. So I'm going to subtract k. I recognize I can reduce it down. Divide everything by 2 to make it easier. Now you can factor it a lot easier. That's positive 3 and negative 2, and then solve it. Recognize the only answer k can't be is 0, so both of these are good solutions. 49, Again, we have monomials in the denominator. So a monomial means it's 0. Need common denominators. So I'm going to write that as 3m over 3m so that we now have common denominators. Then write down only the numerators once the denominators are the same. And then combine like terms and solve it. And make sure that answer doesn't match your restriction, which it doesn't. And so the answer is -1. Number 50, we almost have common denominators. We're going to multiply this by x. If I multiply this by x, they're exactly the same, all the denominators. And now write down only the numerator and then solve it. That's 2x minus 2. Subtract x, add 2. And you have your answer. Oh, and what can x not equal? So x cannot equal 0 because of the x. And here, x can't equal -2 over 4 or -1/2. So those are the two restrictions that would make a 0 in the denominator. 2 is a good answer. Turn the page. Number 51. I'm going to factor this so I can see the restrictions better. So if I factor it, the only number n cannot be is -2. That's what makes a 0 in the denominator. Any common denominators? So I'm going to multiply 3 by n plus 2. I'm going to take -1 by n plus 2. And then the last numerator stays the same. And just solve that. Combine like terms. I'm going to subtract 2n and add 4. And then divide by 2 and you get your answer. And that's it. And be careful, that is not a restriction, which it isn't. Number 52. Factor it. And then look, what can n not equal? So n cannot equal 0 or -1. Make the denominators the same. So this denominator needs n plus 1, top and bottom. But I really only want to focus on the top. So n plus 1 times 1 is that. The rest are going to stay the same. And that's what I'm going to solve. So 1 take away 1 is 0. Add n and subtract 1. And then divide and you have your answer. So add n and subtract 1, divide by 2, and you have your answer. A couple more left. Factor. And then think, what can n not be? So n cannot be 0, and n can't be +6. That would make a 0 in the denominator. We need an n, top and bottom. We need n and n minus 6, top and bottom. And the last one can stay the same. Multiply it out. Plus 6n. Notice the n squares eliminate, combine like terms, and then solve it. Number 54, factor. So n cannot equal 0 or positive 2, because that would make a 0 in the denominator. This last fraction needs an n, so it can match the others, top and bottom. So we have 5 equals 1. And then we have negative n squared and negative 4n. To solve this, I'm going to add n squared. I'm going to add 4n. And I'm going to subtract 1. I'm going to factor it. What do we have? It's not factorable. I did something wrong. So 5 and 1, negative n squared and negative 4n. Added n squared, added 4n. Oh, when I subtract 1, it's positive 4. See, I knew I made a mistake. Because this is n plus 2 squared. And so the only answer is negative 2. 55. We're glad we're doing it together, right? So factor. Write down what x cannot equal. So x cannot be 0 or positive 2. Now make the denominators the same. So I'm going to multiply by x minus 2 and x. This needs an x minus 2. Now all the denominators are the same. So the numerator, that's x squared minus 2x. That's 3x minus 6 plus 6. Solve this. The 6's cross out. Subtract 3x. Factor out an x. And I get the two answers 0 and 5. X can't be 0, so that's extraneous, so the only solution is 5. Last one. Look at the denominator. M cannot equal 0. Make common denominators. So I'm going to multiply by 5m, top and bottom. So that's 5m subtract 1, squared minus 5m. These are common denominators, so I can just put them together. And that's what I'm solving. Subtract m to both sides. Two take away 3 is negative 1. So add 1 to make it equal to 0. And now we're going to factor this. So this is negative 5 plus 1 makes negative 4. So one answer is negative 1/5 and the other answer is positive 1. Double check. They both work. No extraneous solutions. And we're done. Mr. G Math over and out. Until next time. I'm proud of you for doing your work.